Shri Gurubhyo Namaha, children. Hope yesterday you went through the concepts of microscopic model of current. Today I am going to continue with Ohm's law. I am going to continue deriving the derivation of Ohm's law, which is the macroscopic form today. Okay, I am going to derive the definition of Ohm's law with the formula of current density. Now hope you remember the formula for current density, which is current per unit area, which is nothing but current density, and it takes the unit ampere per meter square. This is what we learned yesterday. Okay, so I'm going to continue with the current density. The formula is where is the formula? I can write here. J is equal to sigma into E. Okay, and one more formula for current density, J is equal to I by A. Current flowing per unit area is current density. Let me write here. J is equal to I by A. J is equal to sigma into E, where sigma is nothing but you call it as conductivity. So with this formula, I am going to derive Ohm's law. Okay. Now look at this diagram, children. Now this is a segment of a conductor, okay, which is a wire, and the length of the wire is L, and its area of cross section. Area of cross section is determined using dotted lines there. So area of cross section is A, length is L, and you apply a potential difference. Now this wire is connected to an external battery with positive and negative terminal. Now this gives potential difference. Okay, so this is applied across the wire. So as soon as a potential is applied, you have electric field. Look at the arrow. Now this is the direction of electric field and the direction of current. So electric field from positive to negative. This is the direction of electric field, and there will be a current flowing in this circuit. Okay, and the electric field is uniform. It's a uniform electric field that is created. So based on this, I will write the formula for potential. Potential V is equal to E into L. Again, potential difference formula, V is equal to E by D. Right? D is the length of the conductor. Here we have taken the length to be L. So I can have E is equal to V into D. Same formula I have substituted here. Instead of D, I have substituted L. So V is equal to E into L. The potential difference or the voltage is given as V is equal to E into L. Right? And we know the magnitude of current density. I have already written the formula. Current density J is equal to sigma into E. Right? So I will write that formula once again here. J is equal to sigma into E. That is equal to sigma. Now what is E here? What is E, children? E can be written as V by L. Am I right? Okay, so I have substituted instead of E, V by L. Okay, ma? Right. Not is a current density formula. Current density formula, J is equal to I by A. So I by A is equal to sigma into V by L. Now I rearrange this equation, bring this V to the left side. So when I bring this V to the left side, on the right side I have I into L by sigma into A. Okay. Now look at the equation here. In this equation I have the value of current, length, sigma and area. Now all these are to be considered constant. L, length of the conductor, is going to be constant. There will not be any change. Sigma is going to be constant. A, area of cross section. So which alone will be a variable here? Current. So I replace all these terms. Okay. So the quantity L by sigma A is called as resistance of the conductor. So what is this? It is called as resistance of the conductor and it is represented by capital R. Okay. So, I can write this formula as V is equal to I into R. So, this is considered to be a very important formula. Now, this is called as macroscopic form of Ohm's law, which you are learning from your lower classes. Okay, V is equal to I into R. Are you able to understand? So here I am going to define what is resistance. Now I can find the value of resistance to be R equal to V by I. So how do you define resistance now? If resistance is defined as, it is the resistance is ratio of potential difference. PD is potential difference across the conductor to the current I, current passing through the conductor. Okay, so this is the definition for resistance. Okay, and the unit for resistance is ohm. Okay, or like this, unit of resistance is ohm. Hope you are all familiar with all these things. You have already discussed all these values in your previous classes. So the unit of resistance is ohm, right? So this is about Ohm's law. Now the Ohm's law is derived from current density. Okay, right. Now this is a graphical representation, children. Now when you draw a graph between voltage and current, now here voltage is taken along the x-axis. X-axis you have voltage and y-axis you have current. Okay. Now when you plot the points in a graph, now this will be a straight line. Okay, because as per the Ohm's law, V directly proportional to I. Okay, this is what we saw. Okay, so V proportional to voltage is proportional to current. So when the voltage is changing, current also will change, and it change linearly. The graph is a linear graph, and the slope of this graph. Okay, now here it is, this is how you take the slope. You take 2 points between in the line, and you take slope is equal to y by x. Y by x is I by V. Actually, V by I is resistance, I by V is 1 by resistance, right? Yes or no? I is equal to, what is the formula for Ohm's law? Just now we read R is equal to V by I, or I is equal to V by R. So if I want to find out the value of resistance, V should be, actually this is the slope. Here it is y by x to find out the slope, but it is I by V. Okay, instead of V by I, it should be I by V. So the slope is 1 by R here. The slope of this graph will give the value of 1 by R, from which we can find out the value of R. But look at this graph. Now this is with respect to all the materials which conduct, conductors. So whenever we talk about a graph like this, which is a straight line, these type of graphs are said to obey Ohm's law. Okay, obey Ohm's law. That is why you have a linear graph. That is, change in voltage will give rise to change in current. But look at this graph here, children. Now this is applicable for conductors. Now because conductors obey Ohm's law, whereas here actually this is a graph, I don't know, we are going to learn this in the next volume, children. Semiconductors we are going to learn. Now in that semiconductors we are going to learn about a diode. Okay, in this actually diode is a semiconductor device which does not obey Ohm's law. Does not obey Ohm's law. Okay, so when you plot a graph, when you plot a points with v along the x-axis and I along the y-axis, the graph will be like this. Now here the graph is not linear. So if the graph is not linear, then you can say that this graph does not obey Ohm's law and it is a non-ohmic device. Non-ohmic device in the sense they do not have a constant resistance. Ohmic device will have a constant resistance, whereas non-ohmic device will not have a constant resistance. So this is the graphical representation of resistance. Whenever you have a linear variation, then you say that graph obeys Ohm's law. Clear? So with this, let us move on to, before going on to the sum, I wanted to discuss one more thing on which the factors, okay, I'm going to discuss, let me write here then, factors on which resistance depends on. Okay, so let me write here, otherwise write here, factors. I'm going to discuss a very special case of resistance. Now what are the factors on which the resistance depends on? Resistance has a direct dependence on the length of the conductor. Now whenever you increase the length of the conductor, its resistance also will increase. Similarly, it also has an inverse proportionality with area, in the sense whenever the area is greater, resistance will be lesser. Whenever the area is going to be lesser, resistance is going to be greater. So when I compile this, actually this ratio is a constant, children. You cannot say that proportionality here it is just a constant, like how we read for capacitance. Now capacitance formula, hope you remember, C is equal to Q by V, and I said the capacitance of a value depends only on what? The effect of dielectric medium. We discussed so many factors. C is equal to epsilon naught A by D. It depends upon the medium, it depends upon the distance between the plates, it depends upon the effect of dielectric. All these things we were discussing. Similarly, here also the resistance, whenever we talk about resistance, it is just a constant here. The ratio of V by I is equal to constant. Similarly, in light we read the ratio of speed of light to speed of light in vacuum is a constant. But what are the factors on which, suppose this does not depend, but what are the factors that depends on? Means this is the factors. Okay, resistance depends on L, resistance depends on area. So when I compile these two, I have the proportionality of resistance to be L by A. So I need to replace this proportionality by a constant called rho. So this rho is nothing but you call it as specific resistance. What is this, children? You call this as specific resistance, or you also call it as resistivity. Resistivity, whose unit is ohm meter. Resistivity, the unit of resistivity is ohm meter. How do you get ohm meter? Now rearrange this formula, R equal to rho into L by A. Get the value of rho. So rho will be R into A by L, right? Yes or no? Or I will write here. Rho equal to R into A by L. Rho is, resistance is ohm, area is meter square, length is measured in meter. So here it gets cancelled. So here is the unit for specific resistance, which is ohm meter. Okay, so rho is equal to, I can write the formula, rho is equal to R into A by L. Okay, and I'm also going to introduce what is called as conductivity. The reciprocal of resistivity is conductivity, which is represented as sigma. Sigma is equal to 1 by rho. Now these are some important formulas which are used for solving the problems. So all these formulas you have remembered, whatever formulas I have written, J is equal to sigma E, V is equal to EL, V is equal to IR, R equal to V by I, and the formula for resistance, specific resistance. All these things you should remember. Specific resistance, now resistance depends on what? Just now we saw Resistance depends on length, resistance depends on area, resistance depends on the nature of the material, and specific resistance, what we discovered, what we wrote now, specific resistance or resistivity. Now this is a special property. Now it does not depend on any other factors, but it depends only on the nature of material. So resistivity always depends on nature of the material, whether you change the length of the conductor, whether you change the area of the conductor, but resistivity or specific resistance depends only on nature of material. Okay, now in your textbook, in page number 90, they would have discussed a tabular column where they have given the values for resistivity of various metals. Okay, it has been discussed. Now semiconductor materials, actually based on the resistivity of the materials are classified as insulators, semiconductors and conductors. Okay, now this resistivity plays a major role in classifying the materials. So materials are classified based on their resistivity as insulators, semiconductors and conductors. And we have the formula for resistivity as rho is equal to, what is the formula for resistivity? Look at this. Rho is equal to R into A by L. Now when A takes the value of 1 meter square, when L takes the value of 1 meter, substitute in this formula, rho becomes R into area is 1 meter square, L is 1 meter, then the resistivity is equal to resistance. Now this is also a very important formula. When the resistivity is equal to resistance, the electric resistivity of a material is defined as the resistance. Now here I define according to this. The resistivity of a material is defined as the resistance offered to a current flow by a conductor of unit length. Unit length is when the length is 1 meter, and unit area of cross section, when the area becomes 1 meter square and length becomes 1 meter, then specific resistivity is, specific resistance or resistivity is equal to the resistance of the conductor. Is it clear, children? It is the resistance offered to the current flow when the length is 1 meter and area is 1 meter square. Okay, and I also discussed the unit for resistivity, ohm meter, resistance ohm, resistivity ohm meter. Is it clear? Is it clear? Conductivity, what is the unit of conductivity? Conductivity, I said sigma is equal to 1 by rho. So rho is ohm meter, conductivity is mho, the inverse of ohm. Okay, instead of OHM, we will write mho per meter, or I can also write like this, per ohm per meter. Now this is the unit for conductivity. Also you should remember, these are very important short questions. 1 mark questions it may be asked us. So you should remember all these things. Okay, clear? Are able to understand, children? Next we are moving on to a problem based on this. The resistance of the, now this is an example problem 2.6. Now the resistance of the wire is 20 ohm. So let me write R1 as 20 ohm. We have to find out what is the new resistance. Let us take the value of new resistance R2. Okay, what will be the new resistance if it is stretched uniformly? 8 times its original length. So let us consider the original length as L1, which is equal to L. Now L2 will be 8 times L. Hope you understand the question now, right? Resistance of the wire is 20 ohm, which is taken as R1. So corresponding length will be taken as L1, which is taken as L. Then what will be the new resistance R2 if it is stretched uniformly 8 times its original length? So it is 8 into L, right? So let us write two formulas here. Now first formula is original resistance, that is without changing the length. So original resistance is taken as R1 R1 equal to specific resistance will not change. As I said you, the material is the same. So specific resistance remains the same. So it is L1 by A1. Okay, ma? Right, the next one is new resistance. New resistance is taken as R2. Again, the specific resistance material is the same. It remains as such. Okay. Now here instead of L2, you substitute 8L, right? 8L by A2. We are going to substitute the values, but before that, L2, let us write initially as 8L. Now what is happening to the wire? The wire is stretched. Look at the question. The wire is stretched. So when you stretch, okay, though the wire is stretched, the volume remains unchanged. Okay, volume remains unchanged. Which alone is varying? Length is varying. Okay, volume remain unchanged. What is the volume formula? Volume is area into length. So area L1, A1, L1 equal to A2, L2. Okay, ma? Now substitute the values of A1, L1, A2, L2 and all. So here I have A1. Instead of L1, I will substitute L because L1 is L here. So A1L is equal to A2 into 8L. Am I right? Okay, so I will write ratio of A1 by A2. So ratio of A1 by A2 equal to 8L by L. Okay, ma? Now here LL gets cancelled. So I have 8. Okay. Now the next step is by dividing equation R2 by equation R1. I am finding out the ratio of resistance once again. So R2 by R1 equal to, what is R2 formula? R2 is rho into L2 by A2 divided by rho into L1 by A1. Okay. Now substitute. So rho into 8L by A2 into, this A1 will come to the numerator, A1 by rho into L. Okay, ma? So rho and rho gets cancelled. L L also gets cancelled. So R2 by R1 equal to A1 by A2 into 8. Okay. Now we have the value of the ratio of A1 by A2. A1 by A2 is, what is the value? Here I have done A1 by A2 equal to 8L by L equal to 8. So here it is 8. So substitute R2 by R1 equal to 8 into 8, which is 64. I want the value of R2, right? So 64 into R1 is 20. So 64 into 20 will be 1280 ohm, which is the value of R2. Okay, ma? So this is one problem, and this is a book back problem, children. The first problem, page number 123. Look at the graph. Super question this is. The following graphs represent the current versus voltage and voltage versus current. So the first graph is voltage versus here current, and the second graph is current with voltage. Okay, so V by I. Now V by I will give the value of what? Resistance. I by V will give the value of 1 by R, correct? You have to understand this very clearly. When I was just now we were discussing about this. I was just discussing how the graph will be for conductors, non-conductors and all. I was telling V by I and I by V. Okay. Now the question is which conductor has least resistance and which has maximum resistance. I am going to write the resistance value for all the points. There are 6 points, children. Okay. So let us start with RA. Now where is A? So the resistance of this graph. Now all these things will give the value of V by I. Resistance is equal to formula. What is formula? V by I. So V is along, already it is there in the Y axis. So no problem, we can substitute the values. So what is V here? V with respect to this point A is 2, right? Yes or no? So 2 by, what is I? I is 4. Now I wanted to have this value. But with respect to point A, அப்படின்னா I is 4 and V is 2. So what is V by I? V by I is 2 by 4, which is 1 by 2, which is equal to 0.5, right? Similarly, RB is this point. RB, V is 4 and I is 3. So it is 4 by 3, which is 1.33 resistance, no? So I will write the unit, ohm. Similarly, RC, it is 5 by 2, yes. So it is 5 by 2, which is equal to 2.5. Now all these three values, it gives the value of resistance, which is equal to V by I. Okay, now next next graph. Now this is RD. If I wanted to find out, I have to go for 1 by slope, because V is along the x-axis, I is along the y-axis. So it is 1 by slope. So again we will write what is there. It is 4 by 2. Okay, 4 by 2, which is 2 ohm. Similarly, RE, slope 1 by slope edukka theriyalena kashtam inga. 1 by slope is, what is the formula again? V by I. Now here it is I by V. If you are going to take the slope for this, here it should be I by V, but our formula is what? V by I. So it is 1 by slope. So 1 by slope, in the sense I will have this value x-axis to be in the numerator and denominator, 4 by 2, which is 2 ohm. Similarly, RE is equal to 1 by slope, which is again 3 by 4. 3 by 4 is 0.75 ohm. Similarly, RF is 1 by slope, again it is 2 by 5. 2 by 5 is 0.4 ohm. Now all these are resistance, which gives formula 1 by slope. Again it is 1 by slope, in the sense 1 by V by. So it is again V by I here. Is it clear? Is it clear? Now question is, which conductor has least resistance and which conductor has maximum resistance? Now all these are decimal values, very low values. Now compare these values, which one has got maximum value? Maximum value is 2.5. So this RC has maximum resistance. RC as maximum resistance, and which has got the minimum resistance? This is 0.5 to 0.17. This has got the least resistance, RF. This is having the least value, 0.4. So this has got minimum resistance. Are you able to get my point? Okay, now there is one more problem in page number 124, children. That is your homework for today. 124, question number 3. A copper wire of 10 power minus 6 meter square area of cross section carries a current of 2 ampere. So area of cross section is 10 power minus 6 meter square, children. Area of cross section is given. Current value is given. Current is 2 ampere. If the number of electrons per cubic meter is 8 into 10 power 28, so n is given. So the value of n is 8 into 10 power 20, small n. Calculate the current density and average drift velocity. Now you need to find out what is current density. Current density formula, J is equal to I by A. So I by A, I is already given. I is 2 ampere and A is 10 power minus 6. So substitute, you will get the value of current density. Okay, next is average drift velocity. Average drift velocity. What is drift velocity formula? Current and drift velocity, I is equal to NEAVD. Now n, of course, it is 8 into 10 power 8. Now I want the value of drift velocity here. So rearrange the formula. VD is equal to I by NAE. Rearrange the formula. Substitute the value of current in the numerator as 2 ampere divided by N is 8 into 10 power 28 into area is 10 power minus 6 into charge of an electron. Charge of an electron is 1.6 into 10 power minus 19. So that value you substitute. I have already told you how to take the log calculation. So using the log calculation, simplify this sum and send me the answer. Okay. So this is your homework for today, and apart from that you will write the 5-mark answer, okay, which is pending in the first chapter. I want you to write that capacitor series parallel, that you write, or effect of dielectric. Page answer 20, question number 20, you write once and then send me in the WhatsApp group. Okay, see you children.